Okay, for your exam review number 6, we have a problem here that asks the sum of two numbers is 20. So since we don't know what the numbers are, we're going to pick two variables. So I will pick m plus x, because that's a sum. It equals 20. Now the second part, it says what is the possible sum of their squares? So we want the least possible sum in this case. So the squares of the two numbers will obviously be m to the power of 2. Sum is an addition again. X to the power of 2. So we don't know what this least possible sum is. So we'll just call it y. It's another variable, something that's unknown. So right now we have too many variables, so we have to combine these two equations together. So we'll call this one number 1. Second one for the sum of squares number 2. So we'll isolate one of the variables. I'd like to be able to write everything with just y and x, because that's what we're used to seeing. So that means I'll isolate m by moving the x on the other side by subtracting it. So on the left-hand side, subtracting x becomes 0, so the m is now alone. On the right-hand side, there's no other x's. So I'll have to keep the 20 there and subtract it like this. So this is now my new equation number 1. Just erase this so it's a bit more obvious. So now we want to combine these two together. So we'll take number 1, we will substitute that into number 2. What will happen is you get your y equals, so instead of m, we will write 20 minus x. Since we just determined that m is the same thing as 20 minus x, substitution means you remove the original variable, which was m in this case, and we exchange it for its other value, which is 20 minus x. Now for the rest of the equation, we're left with the plus x squared. And you'll notice that on the equation now, we just have two variables on the right-hand side. Instead of m and x, we're down to just x. So we will develop this, or expand it. So we have 20 minus x to the power of 2. So we'll use the binomial expansion, which means square of the first term, and then double the product, and then square the second one. And we can't forget the x squared that's already there. So this x squared is that one at the end. The first one here, that's just from expanding. So now we have to simplify this a bit. We have y equals 2x squared minus 40x plus 400. Now, we have to find the least value. So you'll notice this is a trinomial. It's got 3 terms, and it's a power of 2. Now, this looks like a parabola. So a parabola does have a vertex. So the vertex is either a maximum or a minimum. And you'll notice here that the first term, like the dominant coefficient, is plus 2. That means that the branches are aiming upwards. So if we looked at a graph of this, we can already guess a bit what it looks like. We know that on the y-axis, it hits at 400, and we know the branches are aiming up. So it's either going to be something like this or like that, but we know we have a minimum. This here is the minimum that we're looking for. So how do we find that? Well, we have to change it to the vertex form. So once we have the vertex form, we'll be able to know what that value is, which is what we're being asked. It's the smallest value of y that works. So I'll make this a bit simpler by making the numbers smaller. I'm going to take out 2 as a common denominator. So we have 2, open bracket, x squared minus 20, x plus something. To get the vertex form, we have to complete the square. And then we have the plus 400 that's already there. And I'll have to remove whatever I add. So To find out what goes here, which are our c value, essentially we have the c value in ax squared plus bx plus c equals b over 2 squared. So in this case, we have minus 20 divided by 2 squared. Now minus 20 divided by 2, that's minus 10. Minus 10 to the power of 2 will be exactly 100. So here we do plus 100. Here we do minus 100. Okay, and I just noticed that I forgot to divide my 400 by 2. It should be a 200 here. Because when I took out common denominator 2, which is over here, I had to divide all the original terms, which were the 2x squared, the minus 40x, and the 400. So just get those little marks out of the way. Okay, now we can finish this. We have y equals 2. Now we'll put the vertex form for this one. It is x minus 10. So the way you figure this out is the sign stays the same. And then this minus 10 is either half of 20 or the square root of 100. It should be the same. If it's not the same, that means that you haven't completed the squares correctly. Now there's a power of 2 that goes here, and I will add a square bracket here just so I don't mix things up. So here when I add the square bracket, I'm left on the outside with 100 negative with the plus 200. That becomes plus 100, like this. And I will expand this again to not have that double bracket. So 2 x minus 10 squared plus 200. So what we have here is the vertex is 10, 200. So that means this is a minimum, and the value of x equals 10. So I go back to what I was doing. I'm supposed to find two numbers. Now I had m and x. I've already found x, so to find m, I just have to substitute into this equation that I already have, which is m equals 20 minus x. So we take the value of x, we substitute that into our first equation. That means m equals 20 minus 10, m equals 10. And those are the two answers that we're looking for. Go back to see everything at once. We asked for the sum of two numbers is 20, so we have m plus x equals 20. Then we have the sum of their squares, m squared plus x squared. We want the least value, that's an unknown, so we have to use a variable. Then we take the first equation, we substitute the variable we want to get rid of. So I don't want any m's, so I do m equals, and it's isolated. And then I do a replacement, so I put 1 substituted into equation 2. The m disappears. I develop that. I get a trinome with the power of 2. Since I want to find the minimum, I know the minimum is part of the vertex, so I change that to the vertex form by completing the square. And once I've finished completing the square, I find the values for the vertex. I just need the x, because that's one of the numbers I was looking for. And the other value is m equals 10. So those are my two numbers. And the question was asking what is the least possible sum. So in this case, that answer would be 200. Sorry, it would be sum of squares. Yes, it would be 200. So we'll write that out. So we know it's m squared plus x squared is 10 to the power of 2 plus 10 to the power of 2 again is 100 plus 100 equals 200. We could have used the value of 200 from the vertex, but here we went back to our original question which asked for two numbers, and we used those numbers with the sum of squares, which is y squared equals m squared plus x squared, to determine that it's 200.